The last talk for today's session in the fifth Balcon is Mr. Igor Pecovnik with his talk about Armbian, which is Linux for development boards. Please give him an applause.
Thank you. So, ladies and gentlemen, welcome to my presentation. 4 years ago, it was mid-2013, I have a small dream. I have a dream to set up my email server at home. Nothing special. And ARM-based computer seems like an obvious choice. Raspberry Pi A at the moment, but it was not very interesting for me. It was quite a toy, actually, barely designed toy. And I searched further, and I found a Qubit. It can run a Debian, but on a much better hardware. Gigabit, 2 gig of RAM, dual core SATA, battery powered. Wow. Of course, it was not a perfect device, but it is a reason that the project began. So quick facts, Armbian is a community project. It's open source and licensed under GPL 2.0. This will tell a lot about the project itself. It's mostly sponsored by our private resources. I will present the project from my own perspective. So let's briefly check who I am. I'm the founder of this project, the maintainer. I'm full-time employed actually at this project right now. And beside me, there are two or three people I can count as a semi to full-time. I'm a small business entrepreneur. My field competence, I study math and computer science, but later I also proceed to human science and philosophy, but not formal way, the last part. I use computers since 80s. Since the Spectrum, then my first Linux experience was 0.9 kernel in Slackware 1.0. That was 1993, I think. I have 2 kids, age of 3 and 6. So let's check what Armbian is actually. It's Debian and Ubuntu, something very, very generic, but it's working on 70 boards at the moment. 1/4 of those boards are work in progress, 1/4 are already end of life. So we are now 4th year, we are working on this project. We maintain more than 30 ARM and ARM64 different kernels. There are a lot of official unofficial ports for TV boxes, which are actually maintained by community members. We don't deal with that. But the similarity between TV boxes and development boards are quite big. So they're actually packed into nice boxes and sell as TV box. Usually they come with Android, but we want to use it for pure Linux. We managed to build very powerful build tools, which were actually the first step in this project. I want to have one way to build everything with one click, let's say, or with one punch on the keyboard, and we actually succeed that. We have stable and beta repository, which is updated daily, and we also have very good reputation because we are brutally honest. We don't hide anything. The project is really, it's open source like it should be. The presentation, it will short show the motives for start, which were the basic ideas which led me to initiate the project. Actually, I bought this device and I want to use it. That was my personal motive, but this motive is expanded later. I will proceed then to historical overview how the project evolved through the time. I will show you the infrastructure which we use right now, and the user space. How is our Debian different than some generic Debian or Ubuntu? And I will close it with the build engine, just overview how it is done. So motives for start, I only wanted to run a Debian server on ARM-based machine. And this was the board for the project, which I bought 4 years ago. The software development kit which was provided with those boards was rubbish. It was completely unusable. And if you want to use this machine, which looked very good, and it's still today, it's quite interesting board, you have to really dig deep into the kernel to fix things. But at that time, it was a brick, actually. It was very, very bad. I simply forgot about this board for some time because it was not possible to use it for the purpose which I wanted to use it for, to serve my email. You cannot run email server on such a rubbish hardware. So my early motivation was disappointment because I bought the brick, and the curiosity, what I can do to improve this, to make this brick work. And of course, to finish, I had this idea what I will put on this machine. From web server to NAS I also plugged the scanner, printer, everything. It's powerful enough. A year later, I end up with this. Actually, this is the project realization. It's based on one A20 machine, which is there. There is a fiber converter. So everything is designed from scratch. Even the box was cut out and draw. It's handmade, everything. From the software part to the box which stand on my wall, and when I approach it, I saw which buses are approaching on the left side of my condo and which are. So it's really some practical usage, and of course it works. Everything what I show it on the picture, all those services are running on such a small machine. Historical overview. I will proceed quickly. I only wanted to run a Debian server again. I joined QBboard community to start getting some information to see what we can do together, and not just I, because I can do nothing actually. And I see some people were already doing some progress on this kernel. And I start to work on this bash script, which later become that gigantic, powerful tool which can bring sources together, and you get a bootable image with very clean operating, with clean Debian, with utilities and everything. So I fell into the cycle, and other people started to join this initiative. And my work actually quickly got attention by companies, and they start to send me some boards. I moved things to GitHub. So before I was just doing at home some small project. Then I moved to GitHub, and people start to join, and hey, let's do this way, and we start to work together. Everything was pure hobby project. I didn't have anything else. Like I have those 3 boards. Early in the project, we start with the Ubuntu Trusty. Downloads were on public servers because there was no intention to do anything seriously. This is the equipment which I had at the time. Practically nothing. Actually, I was doing something else at that time in my life, and I moved a lot. And actually, I only have one small old desktop computer, one 19-inch screen, and exactly this voltmeter. So couldn't do much of diagnostic with this kind of equipment. But motives keep me up. So I want to learn. I'm not a hardware guy in essence. I'm a software developer. So I know little about electronics, but not enough to solve all problems which were in this area. So I want to learn, and I want to help people which were in worse situation that I was. There were a lot of people who were not even close to my knowledge, let's say. And I like to make things, not just blow up. I like to make them. So, nevertheless, things quickly progressed. 2014, we start to think to do things more seriously. I bought a domain. I just thought we need a name because every project needs a name. I search ARM and something. What can we Armbian? Oh, it's free. It's $10. Let's buy it. So that's how actually the Armbian.com was established in 5 minutes. And also, this basic infrastructure is really simple. We don't actually need much. It's a WordPress blog and with all the simple informations. But 2014 was a jump. We start to get boards. Boards start to come in, and people, the crew expanded. We spent months in just examining system D problems. Everybody who are familiar with this, with system D related troubles knows that it could be painful, and we really we almost gave up to introduce system D, but eventually we managed to fix all the problems, and now we have a system with system D, and it's working very well. We also got the first server. Some guy approached to me. Here is unlimited server. Here is €200. Do you need anything else? But it's a normal guy. It's like it's not. It's an ordinary man. And he said, "I have a free server. Use it." And we still use that server. It is in Estonia. So community actually. Put all resources to this project because they see a potential. Repository we use aptly. If you are familiar with it, community forums on IPS. That was also we managed to set up in this, let's say, in the middle phase in 2014. Project was hosting. Everything was actually hosted from, at the beginning it was on A20, on Olimex Lime. I was running everything on it, forums and the website, except download servers in Estonia because he had a good connection. But everything else was here. In the middle time, I need to switch to the most powerful board which I had at home because I wanted to run the project on Armbian, let's say on ARM-based machine, and Odroid XU4 was in service until early of this year, or I think in December last year. We switched it to some more advanced machines because it was not able to go with the flow, let's say. Middle-age problems. We start to rely more and more to documentation, which prove often that it's wrong. That's because the board designer rushed to put out their boards, and of course they forgot to adjust documentations. But when we got the board inside and you start to look to the documentation and it doesn't fit the reality, and you'll lose a lot of time on this. It's almost the same as you didn't look into anything. Then the quality of initial board supports is awful. The kernel which the board maker or the chip maker, they produce some basic kernel, it's awful. there are so many troubles that normal user cannot use it. And we actually, our job here is that we put that rubbish code and put it a few levels higher. We are still a small group. I can count our internal group as around 10 people. It's too small for the size of the troubles, but we do how much we can. And of course, users have very too high expectations, and they think that everything is for free, even our time. So they usually don't give much in return. 2016, we managed to fix video recording on all winner, which is our main section. It's actually running on all 810, 820, H3, and A64 boards. A lot of new boards are coming. First, ARM64 board came in. That means we have to adjust user space. So that was also a little bit problematic because Debian just few months ago they packaged first ARM64 user space, which was not very tested, and problems were on that level as well. So we have to compensate that. eMMC boards start to show up in this year. That's a big progress. It's like it's closer to SSD than as SD card is really, or NAND before. It's let's say eMMC is far more reliable and fast than anything what we have before. And also we put a dedicated build server which is running around the clock, or around the clock, let's say once per day. It builds everything together, and it takes all night. Even it does most of the things in parallel. Present situations, a lot of new boards are coming. So we have to establish torrent download service. As I mentioned before, we have one download location, and that download location becomes a bottleneck when we put out a major release. It's a straight line on the router. Now we have a dedicated torrent network all over the world. So it's community. I said we need this because actually you need this if you want a fast download. Share our images, and we have really good speed all over the world now. Okay, first notebook support came in with Pine, which is actually developer boards with an LCD display. All developers or main developers, we joined under GitHub/Armbian. Before we have all our sources were scattered around our private accounts. We start to use Twitter for I don't know what, but we use it. Project hosting went to high-end servers this year. Problems which we face, the biggest problems is strong pressure on our support. We are just few people, and for example, I just checked a few days ago, the most popular board at the present time, it's around 200 downloads every day. So you can imagine how many people are using Armbian. It's a little bit too much what we can take. Of course, users are failing to use prepared documentation. We invest a lot of time into it, but still, donations, they come. Actually, I have a small paycheck, or a few people, we have a small paycheck out of donations. And the biggest problem, which is from the developer's perspective, is a big hardware diversity. All ARM, or each new ARM platform is you start from scratch actually, and then you have different wireless chips which we also support. Whatever is all hardware which is on the board, we tend to support. Today and tomorrow, well, we are admired, but that doesn't help much. We are somehow de facto standard on this non-Raspberry Pi section. We don't deal with Raspberry Pi, everything else. But here we kind of have a really big share. So this is actually the copy-paste from the Google Analytics. I hope some of us will have a full-time employment if we will continue this in this way. Let's briefly check the current infrastructure. The brainware, it's 5 to 10 people are the core group. Then third party, which are somehow connected to this community, are groups who are digging more deeply into the kernel drivers. We are cooperating with those who are doing with all with mostly with those. Then there are both board makers who also have their own development apartment, usually consistent from 1 or 2 developers. And of course, random participants, they jumped on the project with their own problem and they supply some patches. Look, I fixed this for my own project, and he shared that. That's quite common, actually. And let's say general community gives us actually shaped this project. It's so I have to count them because it's community project. Software, it's very simple. From one side, we use text editor and Git tools. This is daily usage, and of course, everything is around this built toolchain, which runs currently. It runs on any actually, but we promote Ubuntu Xenial because we use it, and it works there 100%. Sorry. Okay, third-party LTs. Okay, services quickly. Those website forum toolchain, download server. This is like, let's say, a minimum or a typical for Linux distribution, which you need to have. Some general information, forums for community, where is the sources or the toolchain downloading, repository with stable and beta. Twitter, we use this. So, user space introduction, it's Debian or Ubuntu, stable only. So we have Ubuntu Xenial and Debian Jessie, Debian Stretch we are preparing, and it will be switched. So Jessie goes out, Stretch comes in. That is the philosophy. So we will provide just this. Anything else, user can do it on their own. We provide separate command line interface and separate one simple XFCE-based desktop. We put on Chromium, Thunderbird, LibreWrite, and that's it. So it's like a plug and play for many people. Serial console is definitely enabled on every board. We focus to this feature especially because it's serial console is it's a basic debug tool, and it has to work simply. So then when you log in, you have to change root password wireless. If it's on board, it's working, and you can connect to your wireless network. And of course, Docker is also supported on all our boards without exception. Just it has to be kernel 3.10 or higher. Optimizations, those are the most important things which actually differentiate our Debian from generic Debian. We focus to how to use memory to reduce frequency of savings, because SD cards, which are typical media of those on those small computers, are very slow. So they were not designed for such usage. But if you make use of memory, then it become much faster, and your SD card will live longer. Unified boot with run disk and UUD. This is something very common on Intel platform, own here not a single board had this kind of boot system. Each board has its own boot system, its own way of booting. So it was a disaster. And we unified this booting scenario, and of course it's much more convenient. We also developed device tree overlay for Allwinner family. If you are using this, you know what does it mean. It's for switching hardware functions on and off on a very simple way. Optimization to dynamic voltage and frequency scaling. We have one guy in the group who is he's completely insane about those. He wants to get down to the best optimization which is possible, and he is doing this. He likes to do that. I mean, he will not stop until he will find that point which will be the best. The file system auto expands. That's also one feature which is good to have on SD media, that you immediately start to use the whole space of your SD card. Headers, kernel headers are installed, so you can build drivers. That's also one cool feature. You just type make. That's all. You don't need to do anything. So we really prepared this for developers, and also for end users and for developers. They can use this from start. We also made a few extra tools to make life easier on those boards. There's Armbian Monitor. It's a base diagnostic tool when seeking support. It also installs web-based monitoring. CPU miner checks SD card for speed. Also, data can be uploaded to pass the bin or logs. So when anybody approaches, I have a problem, type Armbian Monitor -U and show us the URL, and all his logs are there, and we can see what are the problems. H3 consumption, it's for tweaking. You can switch CPU cores on and off and that kind of stuff. The speed of memory, you can disable video output. So if you want to tune up your board to that consumption goes down, and it goes down for really, I don't know, for 3/4 or something like that. You can lower the consumption. In some cases, this is important. Then we have Armbian ARM hardware info and first run. Those are just scripts which apply certain special board settings at boot up or at first run. So we put there some things that we can adjust those boards to the optimum levels, and we can still keep the rest of the system the same. Then we have this Armbian config. You can see it's a menu-driven system for setting some generic things up to, let's say, networking is interesting here. You can enable, disable access point, and it auto-detects you which capabilities of your Wi-Fi interface. It can see it goes up from G to AC, and if your adapter is AC compatible, then your access point will run on AC. So it's that kind of stuff. Also installing to internal memory and software install and that kind of stuff. User problems, again, they don't read anything. They don't understand basic principles of Ohm law. They want, one is, let's say, a typical example is, I have my power supply gives me 5 amps, and I have my phone charger cable, which is micro USB, and I want to power my Tinkerboard. It doesn't go, because Tinkerboard simply needs 2.4 amps that it runs, and micro USB doesn't provide, let's say, maybe 1.5, but it varies from the quality, from the cable quality, from the micro USB quality, but in essence, you will never get 2 amps from this through this connection. And this is actually the number 1 to number 2 problem. Number 1 problem in this world is SD card quality. Number 2 is this micro USB powering, which is actually a disaster, and it's also a disaster on Raspberry Pi, and they need to hack it. They masquerade actually this problem. Well, the built engine, it has 24 source configuration. What does it mean? That means that some boards, of course, we have around, let's say, it's around 70 boards. Some of those boards share, some of them are identical or are very, very close alike, and they share kernel, and they share maybe other things. But we need to operate with 24 sources, and we have up to 3 kernel branches. Kernel branches means we have, usually there is one legacy kernel which comes with the chip. It's usually, it was quickly made kernel which they are using in for Android. And that kernel then we have to clean it up. It's usually a mess full of, also we found some security holes in it. But eventually we fix it and we have it inside, because there are other good points. Currently, video acceleration works only on those kernels. So we have legacy kernel, then we have, I would say, mainline, but it's not completely mainline. It's not directly from kernel org, because there are a lot of patches over those kernels. It's somewhere between, because most of those boards, or half, or let's say, yeah, most, doesn't have mainline support, or mainline support is really, really basic. If you just download kernel from kernel org and you compile it, you maybe will be able to boot the board, but that's it. We use the built engine, the best. It runs on Ubuntu Xenial, but it also runs on Jessie stretched. We use 11 external linear compilers. It runs only, we support only cross compilation for 2 reasons. First is speed. It's obvious. I did a small example on one popular H3 machine, H3 all-winner board. It took 45 minutes to compile latest mainline kernel with all possible capacity, with all cores, and I run it in memory. So I optimize to perfection, but it took 45 minutes, while on my build server this takes 1 point something minute. I compile it in 1 minute and 20 seconds, something like that. Of course, it's a huge box, but still, for developing things, you cannot develop it on the board. It takes a little bit of too much time. So the build engine is menu-driven or it's parameter-driven, and we also implement a lot of optimizations into it. As you can see, the basic principle you choose, you will go for image or kernel, then you just proceed it to either you will get a deb file to install it or image to write on the SD card. But the optimizations, we use apt catcher. If you're familiar with it, it's installed with the system, but you can use it on, you can switch to your company one if you have it. Parallelization, it's done to also down to perfection. I run 100 images at once. I build them at once. I don't have more memory. Otherwise, I would run all of them. So we use compiler cache. User space is also cached. And everything is building in memory if you have it. So this is the release cycle. It's 4 months long. Somehow we managed to come to the 4 months release cycle. In the last month, we engaged external testers to test not all, but most of the boards, and there is constant interaction. So the stable images which are for download, they're all tested. Eventually, because the support is actually too expensive, and we rather test it than answer people how to fix and so on. So this is how far things are done. I hope it was kind of interesting. And let's focus on the end what kind of a legacy this project made. Well, we built the community, which is a central point of this Armbian. It's also a reason of the project existence. Without the community, without the need, it will not continue. And it's also the main resource. Community shaped the tools, and most of donations are actually come from end users, not from companies, from end users. €5 there, €10 there. Of course, sometimes some company approach and give you, here it's 500 or something like that, but mostly end users. Then knowledge, which was built around, we tend to answer just about every question which pops out. We made documentations to limit those questions down as far as it's possible. We made tools which are really powerful, and they are able to manage huge source diversity, and they make life easier. That was the whole point. And we provide some universal system which covers all those boards which are in the spectrum. And we promote open source really with passion. So that was all. Thank you, Linux user group of Novi Sad, for invitation. And is there any question?
Hi, excuse me. I have one question. Why did you decide to go for your own tool chain and not something community-based like Linaro, for example, for cross-compilation?
We actually, for code, we use Linaro compilers. Don't get me wrong, but for everything else, let's say the only alternative would be build root. But build root is kind of it's not designed for this kind of work. First, we don't recompile everything. We tend to create things a little bit, not little bit, much more easier. We bootstrap the Debian system. We compile kernel. We compile our tools. For that, we use and U-boot, of course. U-boot is very important, and that's problematic enough, I would say. We have too much problems already with that. We don't need more more problems.
First, thank you for Armbian. It was the easiest one for me to set up of all the alternatives. Two questions, if you'll indulge me. First, have you come across certain boards that you found were easier to configure because of better vendor documentation or correct documentation or free hardware? Because I'd rather choose those next time. And second, the optimization specific to the boards and stuff like that, has that been contributed to other projects, and by what mechanism does that usually happen, if so?
Thank you. Now, first, there are some vendors which provide really good documentation, but the problem is they are not necessarily commercial successful, which means there is not much community support for those boards, and you're stuck again. You're alone. So, and you alone, you cannot solve the problems. I can see, let's say, this particular problem on perhaps on IMAX platform. I was cooperating with SolidRun, and I must say they do really good documentation. They are helpful. They are really everything, but the community part is not so good, and they are not able to fix all problems which pops out. So from this perspective, it's really hard to say. On the other side, you have Allwinner, for example, where community is really good, and documentation is lousy. It's non-existing. It's really hard to get anything from Chinese that is worth to look into it. The second question.
The special optimizations
Yeah, I would say there were a few spin-outs from our project, one commercial and a few non-commercial, which are actually using our base in total. So they actually built the thing up. So they actually use all those optimizations which are built into the Armbian. Because Armbian essentially was designed to secure a base. I don't care what you will do with the board, but I will prepare you a solid base. That's the philosophy since start.
I mean, like Slackware ARM or Arch Linux ARM, or
they're behind, really.
Yeah.
They're years behind, if you look closely. So.
I have a question. Which is the least specification-wise, the lowest specification-wise board you get Armbian running on, in terms of processor speed, memory, and so on?
Well, the older boards. We still support some A10 boards. Maybe that would be the lowest. Single core, 500 max. But current situation, you have in current situation there are those small NanoPi boards, which are this size. I don't know, 2.5. You have Ethernet connector or without. And it's H3 chip, which is quad core and it's quite powerful. This is the smallest, and they don't put so much memory also on it because you don't need it usually. So.
More questions? Thank you very much.